Hey everybody, it's Jeff. Here it is, version 2, the twin tractor Dolphin. We got a little bit different setup this time. We're going from 6S back to 4S. We're going to use some bigger motors and some bigger props. So let's go ahead and open up the hatches on this thing. I'll show you what it's all about. So the first big change is going to be these motors. This is an F90 1500 kV on a 7-inch prop. The first design was these. Let me see if I can get it in frame here. This is an F60 1950 kV, and we had these on 6-inch props. Motors are quite a bit bigger, if we can get this thing to focus. That is one of the big, massive changes. The other change is we were using this 6S ZOHD lithium ion pack, and now we're going back down to a 4S pack. The 4S pack that we're using is this right here. This is the upgrade dark energy 4S, very similar to a ZOHD pack that everybody uses, except this one, the green is rated at 20 amps continuously. I have another one of these, which is a red version, and it's rated at 30 amps continuously and can also burst 50 amps. This is 5,000 milliamps. I believe the red is 4,500 milliamp hour. And we're going to be going back to a 4S setup. Coming back to the motor pods, I was using the AtomRC. These were an upgraded ESC that they had. No longer using them because they no longer make them. I got a couple of these, but I want to try something different. Inside that ESC cave right there is the Lumineer ESCs that I got from Get FPV. The motor pods had to be redesigned. I've made some changes to them. Now, someone else designed this whole thing. I just kind of hacked it up and made some changes to it. And I shouldn't say hacked it up. I just modified it and just made some changes. I think I made them a little bit better. I've adjusted the profile so it fits this wing super snug. Nice fit. Something I forgot to mention is the spacing of the nacelles from the edge of the wing here. This measurement from here to here is about 55.5 millimeters. In my opinion, the best way to do this is to use your well here for your servo. And then I just run this in. I'll do it from this side so you can see better. I just set this on here so that this edge meets up right with the beginning of that dip. That allows you to easily index it on both sides of the wing. Bada bing, bada boom. Now, my other previous Dolphin, I had them moved in quite a little bit more, but I wanted to make sure I could clear this 7-inch prop to the edge right there. So as long as you line it up with this edge on that, that's perfect. The biggest thing is to make sure that they're just symmetrical from side to side. And again, that measurement is 55.5 millimeters from here to here, give or take. I also had to make a change for this mounting surface because these new motors are a 19 by 19 mounting surface versus these and every other one. You know, your typical motors are a 16 by 16. So we had to modify that. I also modified these so they fit in here nice and snug. And then I also added these ESC holders to the bottom. So it's all one piece here, one piece here. Works great. And again, we're using a 7-inch prop. This is the same prop that comes on the Swordfish. This is a 742, and of course we have the reverse on the other side. This side spins in, this side spins in. So that's the big bulk of the change for the most part, is our drivetrain. We'll come up here to the top, flight controller wise. I'm using a Speedy V instead of that AtomRC one. This is the F405 wing from Speedy V. This is what I was using in my VTOL. So when I was doing my VTOL Dolphin. So you're gonna see I got a lot of power wires. I didn't really just feel like unsoldering everything. So I left the third motor. It's just kind of tucked back in here. Of course, there is no motor. This is a brand new body, by the way. I just crashed that VTOL. I mean, I crashed it many, many times in all kinds of different configurations. She's just getting a little rough. So we got a new body for it. My battery sits right here in the back. I 3D printed just a little square piece This goes right in here on the strap. What this does is when I strap this thing down, holds it in there nice and tight, keep it from moving. We'll pull this out of the way. This tray that's in here, this is, I took like 3 different people's designs and kind of made this my own. Of course, this is going to be for the SpeedyBee flight controller. If you don't have a SpeedyBee and you have the AtomRC flight controller, all you have to do is just take this little top mount off and just use some double-sided tape, and an AtomRC F405 will fit in there just fine. And that'll work just great. So I took this from a couple different people's designs, put some holes in it for a strap. That's pretty much it. It's a very basic piece. I always use these little 45-degree angle pieces. That's just hot glued on the back there for my data link connector. And then on my hatch here, I have a ram air scoop, and I got some vents. And this ram air scoop is going to be nice because before, when I was doing my twin, I was trying to keep my flight controller from melting down. So I installed this ram air scoop because I had my flight controller mounted right here. But now we're going to use this thing for airflow for the battery. So on my red dark lithium battery, if I have airflow on it, I can burst the thing for 50 amps for like 10 seconds. So it'll just be nice. It'll be very nice to keep these batteries cool. And the reason this setup is different from my first one is because I was having an issue where I had to be easy on the batteries. So let's go ahead and let's open up this hatch right here. We'll set this off to the side. You'll notice that in my first Dolphin, and a lot of my other Dolphins, I would take a soldering iron, I'd melt a lot of this foam out, so that way I could take my battery, slide it in, and the batteries would sit like right here. And honestly, this is the absolute money spot for these planes, is to have the battery right here. Helps you from adding ballast to the plane. The only problem is, by sticking it in there, it's a snug fit, and it also it like insulates the batteries. And over time, you're going to cook your batteries. They're going to get hot and hot and hot and hot and hot. And that's the same thing I had with this. I had this thing wedged in there, and I just worried I was going to cook it over a long period of time. Now I should have no issues having it right there. Also, you can see I did a split hatch design, and we'll get in that in just a moment. We'll start from the front. I'll go over my front 3D printed pieces. This right here is from Giz FPV, except there's been a modification. I just added a little bit more ventilation up here. I'm not using this as a camera mount. I'm using this as a source of airflow to get into the plane. This thing is a great fit. He did a good job designing this thing. This thing fits in here perfect. I have some ballast in here to get everything leveled out, and that thing fits in there super snug. Maybe put a little piece of tape on there, but I don't think I'll have any issues. So good job on that, Giz, if you're watching. This right here is my pan camera that I use all the time. This is on a Motion Sick servo that you can get from their website. These things are nice. They're expensive, but they are buttery smooth. 270 degrees of rotation, so you can look back. Just a fantastic servo. This was easy. Just sliced it in there, hot glue, and then it pretty much sits on the top right here, and it sits flush in this cavity here and makes it nice. If I find that I really don't need this, I may go to the factory foam cone just for a little bit more aerodynamic. I like to see the nose of the plane sometimes in my video feed. It just helps me, I don't know, orientation. So we're going to see how this works. We're going to give it a shot. This tray right here, this is a variation from Bonafide Pirate. He made this, and you've seen this if you watch my videos. This actually is designed to go right in here. You cut the foam out, use a soldering iron, whatever you got to do, and then this thing fits in up on top, follows the profile. His is set up for walk snell. Mine has been modified for the DJI, and there's a hole in here too. and these wires feed down in. And I just wanted to try something different, trying to get the weight back a little bit. Just gonna try something different. This is a 3D printed. This is TPU to hold these, to hold the VTX. This thing's awesome. It's got 2 mounting patterns, so you can mount this on a DJI, or you can use the walk snell mount as well. So that's what this is. This is the walk snell spacing, because that's what Keith at Bonafide uses. But this right here is like, it's like a universal adapter for it. Works fantastic. This is held in place by the factory little nub that sticks out. And then I used a toothpick that sits here and that sits here. So when this thing slid on, the toothpicks hold everything. And I used the tiniest dab of hot glue in these corners. Oh, that's even come off right there. But just to kind of keep everything firm and holding. Of course, this is my switch for the VTX. All I did was I used the ground side. Always use the ground side in case you get a power wire that gets exposed. This is ground, you know, so ground wire, on, off. Makes it nice. So when you plug your battery in, you can let everything, you know, get satellites and all that. When you're ready, turn that on, get your video feed and go. The other thing is when you land, instead of trying to hustle and get the battery unplugged because you don't want your VTX to overheat, you can just do this and, you know, you got time to get everything undone, let's just say. I went ahead and I cut my hatch because I am not putting the battery in here. And honestly, even if I did put the battery in here, having this cut hatch is kind of nice. Gives you a little bit more room up here to work. Just wanted to try something different. Some different parts and pieces. Of course, this is my receiver right here. Don't worry, it's broken right now. New one's actually going to be here by the time I get done filming this video. But I just wanted to get this video done while it's nice outside. 3D printed this little rectangle, and this just acts like all the other things, and it just latches underneath there like that with magnets. And then I use these little hatch covers. These are designed by Painless 360. I just scale them a little different, and that's it. Antenna over here I haven't got glued in because these antennas are getting replaced. And I'll have another one right there too as well. So I think that covers all the parts and pieces for the front. Of course, all the links will be down below on my Thingiverse page. GPS mounted here. This is a little TPU piece, so you can actually take that in and out. Just hot glued down to the base. And of course, we went over all the stuff inside of the bay here. And we'll go ahead and we'll flip this bird over on its bottom, and I'll show you the bottom pieces. So here we are on the bottom. We'll start over here on the nacelles. And these nacelles are big. These should fit just about any ESC within reason that you're going to use for a setup like this. You're not going to be able to probably fit 200 amp ESCs in there, obviously. And again, these things are hot glued on here. I used E6000, complete overkill. I just take a bead of hot glue. I go around, give it the wipe at the end, and that is it. There's actually one other thing I do, and I'll flip it back over. These are skewer sticks that go in the top. I put a couple of skewer sticks in there just to kind of align everything and hold it, and then I just hot glue it. The hot glue is nice because you can just put a little bit of isopropyl alcohol on there, and I can remove these things. So if I wanted to, and I have, like I've had 3 different nacelles on this wing, and I've been able to remove them and not destroy the wings. And yes, so these are the ESC holders. These are built into the nacelles. This all funnels down. You will have to cut a channel to make all this wiring fit flat in the wing. You have to cut a channel in here. You'll also have to make the hole where the wiring goes in bigger, just because you're gonna have more wiring to go in there. And that makes a nice clean look. These skids, someone designed these skids, and I'll put a link into them. These are just the way they came. I didn't mess with them. But I did take this and I scaled it down for the front here to make one for the front. This is a must. If you, I guess if you're only landing in the grass, then it doesn't matter. I land on the street all the time. You can land on blacktop, charred, a rock road, whatever you want. And they slide so much easier. They just slide nice and smooth on concrete, blacktop, rock chip road. Definitely a must. And all I do is I set them on there, run these screws in, and then I just do a light bead of hot glue around, and they will not go anywhere. I print them at 100% PLA, so there's plenty of skid life left in them. It's probably overkill, but it's just what I do. And then the servo cover right here, which is really just to make it look the part. There's no, I'm sorry, ESC cover. There's no ESC in there, but I just didn't want to use the wood one. Wanted to make it all look the same. And that, my friends, is it. So let's flip this back over. All right, so last thing I want to show you is the weight on this. This is in grams, so 1.2 kilos is what we're looking at. This is about 200 some grams lighter than the previous setup. And I'm pretty happy with that. Now, there are a couple of things that we could do. We're looking at, if I take this nose cone off, which is our ballast, that's about 100 grams of weight right there. I could probably move the flight controller from here. I could probably move it into here. Try to keep this flight controller as close to the center of gravity as possible. You know, I'm going to mess around with it, trying to get this thing as light as I can. But I think this is going to be a really, really good setup. So the next thing that we need to do is we need to take this thing out and fly it. Haven't even flown it yet. So you're going to get a real world perspective of how well it flies. And at the end of the video, I'm going to share my INAV settings. And let's get out and take this thing up. All right, here we go. First launch, auto launch. Oh, that thing is climbing hard. Gotta get the nose down. All right, we're in angle mode. I'll get a little bit closer to the camera. Dang, dude, this thing's flying pretty good. I'm pulling 10 amps. I'm just letting the flight controller do its thing right now, trying to figure out what it's gonna do. Letting it figure out trims and everything else. We're doing 50 mile an hour. All right, let's go mess around. Let's see what she can do. Let's put this thing in manual. Ooh, we got a breeze coming now too. Actually, let's take a look at everything. Propeller 1. Propeller 2. Everything looks good. Let's go ahead and put it in the manual. Let's go ahead and juice this thing up. Let's see what the max is. Dude, that ain't bad. So that's 30 amps. I'm wide open, sticks full. I'm only pulling 30 amps, which isn't bad. We're doing 72. Of course, we're draining the battery right now, but this isn't that bad. Let's see how it rolls. We'll bring that back. Rolls great. Let's do a little bit more. Dang, that's not bad. Dude, everything's ready to get harvest. Look at the field. Let's pull this thing up. Let's see how it climbs. That's 100%. And we are just climbing straight up. We're doing 30 mile an hour straight up. That lower speed is my 3D speed. And dude, look at this. I'm climbing straight up in a roll. Let's back it down. So if I'm pulling 30 amps, each one of those ESCs is pulling 15. Let's see where this thing will That's not bad at all. Let's crank it. Let's just see if we can't destroy this thing on the first go. That's nice. Dude, this thing handles freaking... I'm in manual. I'm not stabilized or nothing. Let's buzz the tower, Goose. Dude. So, it's doing great. I don't know why the IMU temperature is not working. Let's bring this thing back around. And again, I am only pulling 20 amps right now. There I am. Later. Dude, she's handling well. Dude, she's very stable right now. Bring it up. Roll. This is pretty nice, guys. I'm not gonna lie. Well, that's sweet. Let's get this thing up in the air and let's see what kind of height gain we can get. All right, let's see how this thing cruises. In between my speeds, again, top one is my GPS, other one is my 3D speed. In the middle there, that's my feet just climbing up and down, like how fast I'm climbing. So at wide open, it's climbing at 50 feet a second, 45, 13. That's pretty awesome. Alrighty. Now here's what we're gonna do. We're gonna pull the throttles back. Let's see what this thing does in a stall. I'm in manual mode. Yep, it just gets crazy as shit. Uh-oh. Uh-oh. There we go. Kind of panicked. That was my fault. So it stalls like shit, but it's heavy. You know, it just doesn't have the surface. Let's go back into manual mode. Let's get this thing up in the air. And let's try its cruising capabilities. And again, I'm only pulling 20 amps right now. Not bad. Okay. Dudes, I think we got ourselves a good plane here, man. She's flying quite good. Nope, let's do acro mode. Oops. Definitely need to do an auto tune, and I'm gonna do that right now if I can find the button on my controller here. Let's see here. There it is. Up, down. She's very sluggish right now. That's full stick. Ah, there we go. See, now it's getting a little better. So right now in Illinois, it is, I would say, 90 degrees out in freaking late September. That's nuts. We're just auto-tuning the crap out of this thing. All right. Let's go back into... She's still a little slow in acro, but that's all right. I'm thinking a great success. We just need to do a slight modification to this. Let's go back into angle mode. I don't even know which way I'm looking right now. Angle does good. So this thing can cruise twin engines with twin props. It's cruising at, 9 amps at 37. And everything seems to be in control. Let off angle, comes back, pitch up, comes back. I think we're good. I think we just need to land this girl in manual and see what happens. Tell you what we'll do. Yeah, this thing is awesome. This thing is awesome. There I am. And this is why you put these plastic skids on, because you can land on this road. Look how long your runways get. Way better than a grass field, in my opinion. Alrighty. Let's push this thing up. Up, 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 up. Come back around. And because we got a little bit more weight on this thing, we're gonna probably wanna land it. Actually, you know what? I'm gonna try and land this thing the other way. Again, though, you definitely got to keep your speed up. That is for sure. I think coming in around, I think staying around 40 mile an hour is not a bad number with this weight. I gotta slow my camera down. That thing is way too fast. Now the wind has picked up quite a bit. Yeah, you pretty much gotta bring this thing in and then just kill the power. Of course, I am landing this in manual. We're gonna land it way down the road here. Uh-oh. Oh, I forgot to tape the nose cone. Yep. Where's it at? It's way back there. Hey, in one piece. In one piece. Woo! Let's go get it. There we go, guys. We got her back. That's all this was. It popped off. Should have put a little bit of tape on there. Let's get this thing back to the house. We'll do a final review. I'll share my INAV settings with you here at the end. They'll be updated. I'll make the changes from this flight so you guys can have them. This thing is freaking awesome. I'm so glad I did this. All right, she's back here at the homestead. Dude, this thing did awesome. Absolutely fantastic. It worked. It did everything it was supposed to do. And most importantly, it was stable and fun to fly. Like an absolute blast. Again, you saw if you do this same setup, you're going to need something that can put out 30 amps. If you get an upgrade, and I just don't have mine yet, it's actually going to be here later on this week. But if you had the red version of this, you could just run this thing wide open until you drain the battery. Of course, you're not going to get a long flight time, but you can pull the throttle back. Get this thing down to where it's like 9 amps. So if you want to do a long cruise with it, you can totally do it with this. I really enjoy the camera setup. The pan worked great. I'm going to have all the updated INAV settings at the end of this video. Again, head over to my Thingiverse page. I got all this stuff grouped together. Shout out to Giz FPV, Bonafide Pirate, all the other people. I love building and designing, but I'm a reverse engineer. I try to find something and then I tweak it and change it to make it suit me. And without all those other people making these before me, I would have never gotten this far. So thanks to all of them, and just absolutely fantastic. It worked perfect. This nose stayed in. The only reason it popped out is because I kind of had a hard landing. I've been doing a lot of VTOL lately, so my landing skills, I guess, went to heck. Other than that, enjoy, guys. You'll see more videos of this. We're going to take it out. We're going to give it a proper rip and push it to its limits. And until then, we'll see you in the next video, guys. See ya. Bye.